Now we're going to go over a few other things you need to know. These are energy considerations. Now remember from mechanics that work was equal to the integral of F dot dr. Well, in this case, our force is G m1 m2 over r squared. We want to take the integral of that from a distance r to infinity. Well, G, m1, and m2 are all constant, so we can pull those out of our equation. And all we're left with is 1 over r squared dr, or just r to the negative 2. When we take the integral of that, we get negative 1 over negative 1. Again, we still have those constants. And we need to evaluate it from r to infinity, which just becomes negative 1 over infinity minus a negative 1 over r. Now, we are missing a negative here. Remember that our equation actually includes that negative. And at the very end, we get that work is equal to a negative G m1 over m2 over r. Now, this negative sign should not surprise you, as we already know that work was equal to the negative change in U, or mgh, in this case, potential energy. So that means that G m1 m2 over r gives us potential energy. So our equation again gives us gravitational potential energy. The gravitational potential energy near a planet is negative, since gravity does positive work as a mass approaches. Again, this negative potential is indicative of a bound state. Once a mass is near a large body, it is trapped until something can provide enough energy to allow it to escape. Which brings us to escape speed, which means that our potential energy will be equal to our kinetic energy at our maximums. Again, we know that energy will never change. As the rocket leaves the Earth, its kinetic energy is large and its potential is small. As it ascends, there's a transfer of energy such that the difference between the kinetic and potential will always equal 0. So if we set our gravitational potential energy, maximum, equal to 1/2 mv squared, then what we get is our escape speed. Again, this equation is just rearranged. Again, this is probably one of the most common applications of our gravitational equation, so make sure you include it in your notes.